today is going to be a much more important day in that today we're going to talk about converting between one unit and another. And that's not going to be be able to convert from one unit to another is not going to be the real important part. It's the system and the method that we're going to use to do it. We call it dimensional analysis or the factor label method. That's going to be what's important because we're going to use that all year long in every type of problem that we do. Okay? So we're going to use converting between English and metric system to kind of teach us the method, but the method is what's most important, which is why showing your work is going to be very, very important. It's going to be the most important part of the grade when we do stuff. Okay? Yes, sir?
Is this what the lecture was last night? Because I believe
Was it yesterday? No, it's completely different. But the reality is you can pick up most of yesterday just looking at the PowerPoint. Okay? There was very little math in yesterday. So we have the metric system, the international system, and again, in yesterday we talked about it comes from the French Système International. I don't even know how you say it in French, but that's why they call it the SI system. Our system, the English system, is SAE, and you'll see that if any of y'all work on cars, have tools, or whatever, you have SAE, Standard American English. Okay, so that's our system. We already kind of had the little quiz on our system as far as what we know and what we don't know, right? You know, Peter Piper picked a peck of pickled peppers. How many pickled peppers did Peter Piper pick? Okay, the answer was a peck. Does anybody remember how big a peck was? 8
gallon. Wait, no.
8 gallons?
No, that's actually a bushel. A peck is 8 quarts or 2 gallons. Okay, so again, our system that we refuse to change from that we don't know. Okay, so SI is the abbreviation for it. Again, it comes from the French. It's the international system, but in French it's Système International or whatever, however you say it. And so that's where SI came from. Okay, now it's based on standards that never change. Now yesterday in the video and on the PowerPoint, you would see some of the standards that they use. I mean, they're kind of crazy standards. A lot of them have to do with light and the wavelength of light, or how far a meter is how far light travels in like so many billionths of a second. You know, and it has an exact number all the way out as far as how far light. That's how they define what a meter is. Okay, so it's kind of crazy. We'll never have to know that, but there is a place in France that has the standards for everything, what a kilogram is and everything. But our system is all based upon, you gotta have a standard. You know, back in the, in the olden days when they would go to the market, they would have balances and you'd want to go and get a pound of rice or whatever. And so they put up what was supposed to be a pound on one side, and then they'd add the rice until it balanced out on the other side. Well, if it was an unjust scale, then the guy who put the pound on there was really like a half a pound or 0.8 of a pound. And so you thought you were getting a pound, but it was an unjust scale. And so, you always have to have a standard. You have to make sure that your pound is a pound. And that's what the whole system's about, just making sure we have a standard. Okay, our system of unit, this is interesting, 1866 is when the United States adopted the metric system. We're still not there yet. We're the only country in the world still using SAE, okay? You don't have to know that date, but we are America and we refuse to change, so we use it, but do you know it? And we already determined that we don't know it, okay? Does anybody remember how many teaspoons are in a tablespoon?
3. 2.5. 4.
Okay, that means you don't remember, but it's 3. And how many tablespoons are in an ounce?
6.
Again, we don't know, it's 2. How many ounces are in a cup?
16.
No,
4.
8. Okay, see, so we need to just learn the metric system, okay, but we don't, okay? So we're gonna have conversion factors. Now, a conversion factor is gonna be a relationship between the two different measurements. Everything that we do not everything, but almost everything that we do in chemistry is gonna be some kind of a conversion factor. Okay, we already did density. What are the units on density?
Milligrams per liter.
Okay, you have milligrams or kilograms per liter, right? Well, what would that be a conversion factor between? Mass and volume, kilograms and liters. Whatever the units are on it. And if you have your speed is 70 miles per hour, what's that a conversion factor between? Miles and hours. Okay? Anytime you have something that has 2 units on it, it's a conversion factor between those 2 units. Okay? So we're going to learn how to use those conversion factors today. Okay? So we have a 1 foot equals 12 inches. That's our conversion. We can set it up either way. And really, it's going to tell us if we set it up like this, we're going to divide, but if we set it up like this, we're going to multiply. And that's going to be the whole trick is, okay, do I need to multiply by that number? Do I need to divide by it? The units are going to tell us what we need to do. Okay? So, we already know a meter is the base. We talked about that yesterday. And here are just some conversion factors. Now, you will never have to know these from memory. These will always be given. Okay? So you don't ever have to memorize how many, but we know that a kilometer is shorter than a mile, than 1.61. Okay? So 1,600 meters is about 1 mile. So when they do the mile race, you know, in track, the 1,600 meters is the mile. Okay? A meter is just a little bit, how many inches in a yard? 36. So you got 3.37 inches longer on a meter stick. So here's the yard is right there. So a 100 meter dash is farther than a 100 yard dash. Okay? So the 400 meter is the equivalent of what we used to call the 440, which is 1 lap around the track. So just to kind of give you an idea. Mass, kilogram, again, we're on the MKS systems, meters, kilograms, seconds. Okay? So notice that 1 kilogram is 2.2 pounds. So a metric ton is this, and then here is an ounce to grams. Now again, all of those conversion factors are going to be given, but it's kind of helpful to get an idea of which one's bigger. Because although if I said, you know, grab me an ounce of something, you probably wouldn't even know how much that is either. But a gram is going to be even way, way less than that. Okay? A gram is like I think the mass of a small paper clip is close to 1 gram, like a plastic paper clip. If you want to figure out what 1 gram is. Okay? And what we did talk about yesterday in the video, which is interesting or not interesting, I think it's interesting, is the difference between mass and weight. Does anybody know off the top of your head what's the difference between mass and weight? Okay, the gravitational pull. You watched the video and took notes on it, huh?
No, I ain't read though. I ain't read off the speaker.
No, yeah, it's right there too. Okay, so mass is the measure of how much stuff you have. So if I go to the moon, I still have the same amount of atoms, I have the same amount of stuff in me. But weight is how much gravity is pulling down on you. Okay, and so in the video yesterday, I went and showed how we could calculate your your weight in the English system. The equivalent unit of a pound is called the Newton. Okay? So you can count how many newtons you are. And I was 900 and something newtons, and so I'm trying to keep under 1,000 newtons. But that still makes me feel very large, okay, to say that I'm about 1,000 of anything. Okay? Now, anybody that watched the video, we have a kilogram. What's the English unit of mass? No, that's the English unit of weight.
Slug.
The slug is the English unit of mass. It was a term we've never, ever, ever heard of before. And then I showed you how to calculate how many slugs you were, okay? And most people were 3 point something or 2 point something slugs when you did that conversion. So you're not going to have to know how to do that math on a test or whatever, but I just thought it was an interesting thing to be able to calculate your mass and your weight in newtons and your mass in slugs. So again, on the video, you can go through and do that. And we already know time is the seconds. Now, S is the official symbol for seconds. I tend to use SEC. Maybe it's because I'm a big football fan or something, but I like SEC for seconds, but S is typically the abbreviation. And I'm praying that y'all know this. That there's 60 seconds in a minute, and 60 minutes in an hour. However, sometimes a common mistake is in doing the conversion factor, they do 60 seconds in an hour. And then that gets you messed up. But again, this one you're expected to know. I know that that's high level, but you're expected to know that one. All right, temperature and heat. We've already talked about this a little bit this year, and I just want to we're just going through the units here. I'm going through this, and then we're going to really start working on doing the conversions. But temperature is a matter of, what's kinetic energy measured?
How much the molecule,
The movement. So what happens? Heat them up,
they move more.
they move more. Heat them up, speed them up, cool them down, slow them down. Okay? So temperature measures the average kinetic energy. When is the kinetic energy equal zero? At absolute zero. We talked about the temperature scales yesterday also on the video. Okay? And that there's actually we have Fahrenheit, Celsius, and Kelvin. You're never going to have to convert between Fahrenheit and Celsius. That 9/5 plus, times weight plus 30, the temperature plus 32. You're never going to have to do that. But I kind of talk about where that 9/5 that comes from in the video. You can go back and watch that and be enthralled and amazed. Okay? We talked about absolute zero, that Kelvin temperature scale, that 0 Kelvin is absolute zero. That's what the Kelvin temperature scale is. It's the actual metric unit. Does anybody know how do we convert between Celsius and Kelvin? You're on the ball, man. Add 273. That's again on the video yesterday. So you add 273 to Celsius. So 100 degrees Celsius is 273 Kelvin. Pardon me. 100 degrees is 373 Kelvin. 0 degrees is 273 Kelvin. You just add 273, whatever the Celsius temperature is. But Kelvin is the actual metric unit for temperature. There is an equivalent on the Fahrenheit scale. There's an absolute scale on the Fahrenheit scale that most people don't know. It's called the Rankine, or R-A-N-K-I-N-E scale. And absolute zero on that is negative 459.54. So on the Fahrenheit scale, absolute zero is negative 459.54. That's how cold you got to get to go to zero. And here was a trivia question I asked. At what temperature are both Celsius and Fahrenheit the same? It was negative 40. Negative 40 degrees is the same temperature. So negative 40 Celsius is negative 40 Fahrenheit. That's the one temperature, they're both the same. Okay, that's what the scales cross over. That's a little trivia fact for you. All right, now heat is a total kinetic and potential energy. We'll spend a lot more time. I really want to develop it now, but all the other times the other chemistry teachers don't want to, so I got overruled. But heat is total potential and kinetic energy. It's measured in joules. It's a completely different thing. Now they're related. Generally at heat, the temperature goes up, but that's not always. When you're boiling water, you have it on the stove, and it's bubbling vigorously. The temperature stays at 100 degrees the whole time it's boiling. It never gets above 100 degrees. So you're adding heat, but the energy is being converted into steam. It's being changed into potential energy as they break the molecules apart from one another. And so the difference in the energy is potential, not kinetic, and the potential energy is not measured by a thermometer. And so it's something completely different. Again, we can't really go into it right now because we don't have time. All right, we know about this. As temperature goes up, movement of molecules goes up. We just said that. All right, now this is going to be your cheat sheet that you're going to need to know because this is our system that we don't know. Okay? So we have a gallon is 4 quarts, is 8 pints, is 16 cups, 120 ounces, or 3.8 liters. Okay? All these different things. 1 cup is 8 ounces, 240 milliliters, and a lot of times you can see on a pop can, it has milliliters. We know it's 12 ounces, but then it gives you, I think, 355 milliliters is what the volume is on that. All right, so that's just, but again, these conversions are always going to be given to you. I used to make students memorize the English system just because I'm on, it was kind of like, well, by golly, if we're not going to change from it, we might as well learn it. But I kind of gotten away from that. Because we're America and we don't change, we need, all of these different things we have to be able to convert. All right, Now, in the metric system, we have all of these different prefixes to describe the metric system. Okay? Now, in these are the ones that you need to know. Right here. So we'll practice converting between those two here right in a second, as soon as you copy all this down.
What's the topic of compounds?
Do what?
Definitely.
You don't really have to know the top ones. These are the ones you have to know. Well, this one and these here in kilo. These 1, 2, 3, 4, 5 in kilos, so 6 total. They're the ones, and then even of those 6, centi, milli, and kilo are the favored of those 6. Is this on the screen if I wrote it over here?